Yo, what is going on, everybody? Dan Tramte here, and welcome back to my tutorial series, Browser Noise. This is tutorial number 12, and we're starting a new project. We're going to make a step sequencer. And to do that, we are going to have to learn a few new P5 objects, such as part and phrase. And we're going to look at some new oscillators like sawtooth and square. But to be honest, I think this is going to be our last synthesis project for a minute, okay? We're going to come back to it. But I want to start working with the microphone, and I want to start doing digital signal processes on sound files and stuff like that. And we've been doing only synthesis stuff thus far. But there's a lot of really cool stuff you could do with synthesis, like modulation. And so I don't want to say we're done with it, but we're moving on after this project, okay? So let's get started. Okay, first thing we do, let's go ahead before our setup function and declare our variables, and we are going to call them sine osc for a sine wave, then tri osc for a triangle wave, square osc for a square wave, and saw osc for a sawtooth wave. Then in our setup, we will go ahead and set those equal to a new P5 object. We could do it the old school way, like say oscillator. And not that this is old school. I mean, this by old school, I mean just the way we've been doing it so far. And then you can actually specify the type here. So you could say sawtooth, for example, and then that sine, then sine osc will be a sawtooth wave, which doesn't make sense. But let's actually go ahead and use these pre-made ones. I did not make these. These are P5 objects. And it's not so coincidental that it is the same name, sine osc, right? So then tri osc equals new P5 dot tri osc. Notice that the only thing that is difference between tri osc and the what I named it is simply whether or not the first letter is capitalized. So I'm just sort of trying to stick with some convention here, if that isn't obvious. New P5 dot square osc, and then saw osc equals new P5 dot saw osc. Okay, so now we've created our variables, and we've stored our oscillator objects into those variables. Then sine osc, let's go ahead and specify the frequency. We'll say 900. I'm going to copy and paste that. Change that to tri. Square, it means square, by the way. And saw, and then just change that to 8, 7, and 6. Okay, and then the last thing we need to do, I pressed a weird button there. Okay, is initialize them. So start, boom. Let me just copy and paste that. Boom. That didn't work. I need to actually delete that. Boom. And then whoop. Boom. Okay. Now I press play. That's a pretty nice chord. I like that chord. Okay, anyways. So the next thing we're going to do is we are going to create what's called an envelope. We're going to create 4 of them, in fact, and we're going to apply an envelope to each of those synthesizers. And what I mean by envelope is, okay, if I say la, okay, say if I sing la, you look really closely at what happened, you'll notice there's a period of time that it takes from me to not be singing to reach a peak, like a volume peak. So la, that is the peak, okay? So la, and then what happened is I went a little quieter. Like I decayed a little bit down to some sort of level over, like, that is less than the peak. La, and I held that for a period of time. And then when I release, there's a period of time it takes for it to drop down back to 0. Okay. And currently our synthesizers are just sounding, full volume, just by default. We want it to start at 0, have an attack, have a decay, have a sustain, and release. Attack, decay, sustain, release. And so what that is called an ADSR. Attack, decay, sustain, release. Okay, so let's make that. All right. The way we're going to do that is we are going to say sign_env for envelope dot set ADSR. Okay, ADSR, attack, decay, sustain, release. And we are going to provide values for the attack, decay, sustain, release. That's what we're specifying for our arguments. Just go ahead and do 0.1. That means it's going to take, I think, 0.1 or 0.01 seconds to get from 0 to the peak volume, which we'll get to in a second. The decay is another time-based argument, so we'll make that nice and short. You can totally play with these numbers to see what it's like to have a really long decay and stuff like that. So, but I'm just going with these for now because I've messed with them plenty of times and I know what they sound like. And then we're going for our sustain. We're going to put something like 0.8. And what that means is that's like a percentage from our peak, if that makes sense. So if our peak is 1, then it will decay down to 0.8, if that makes sense. And then our release, so that's how long it takes to die off. I think let me know if I said anything wrong there. I'm pretty sure that's correct. But we also want to set the range. So we're going to say set range, right? And that is just like at its loudest, what is it going to be? So on the attack, we'll just go ahead and say 1 for now. At its quietest, we'll put at 0 because so you can have it so that there's constant, the sine wave is constantly bleeding, like there's still some sound all the time. It's just that every time you hit the ADSR, it gets a little louder and then decays or whatever. But we'll just set it to 1 and 0 for now. Now let's do that for each of our oscillators. So tri-env, square-env, and saw-env. Okay, so now we actually have, I messed up. I skipped a step. We need, right now this sign-env means something to us, but it doesn't mean anything to the computer. We actually need to set it equal to a new p5 object called env. Okay, let's do that. I know there's so many steps, and there's actually a lot of steps involved in this project because we need to make parts, we need to make phrases. You might even make, I don't know, a score, which is phrases sequenced. Maybe we'll get to that later. I'm not sure. But now we have, for every oscillator, we have not only the frequencies set, but we also have an ADSR set or an envelope set, which is going to help us control those sounds. So when I press play, we shouldn't hear anything. That is because we did not set the amplitude of each oscillator's to the envelope that we created. Okay, so so the reason why I messed up is because we need to say sign os.amp. Notice we never specified the amp before, but in this case, think about what envelopes do. It's ramping up the volume to 1, down to 0.8, and then releasing. We're talking about volume. So let's apply the ADSR, which is a thing that steps through various volumes. Let's apply that to amplitude. I'm using volume and amplitude interchangeably, but yeah, we're thinking about the sound level, like the loudness. So if we set our amplitude to the envelope of the corresponding envelope, then we won't hear anything when I press play. So let me go ahead and try. Oh, let me show you a trick. Hold on. Try. Okay, if you ever need to edit multiple lines at once, there's a really cool thing you could do. Let's actually just make a comment, grab that, copy and paste it a bunch of times. And then, so if I have my cursor here on this, at the end of this first hey, I can actually press Command, click, and notice now we have two things that are kind of two lines that are kind of highlighted, and my current cursor, which is where I just clicked, and then like this ghost cursor back here, and I can do that over and over and over again. And what? I can edit multiple lines at once. Yep. So that's a cool thing you could do. You know, the first couple times you use it, it might feel like you've wasted time just trying to figure it out. But if you get really good at that, then like you could be super productive. I'm going to use it right here. In fact, I'm going to put my original cursor here, hold Command, click over here. Now I have two cursors. Now I'm going to do the forward delete thing by pressing function delete. Okay, and then say square. And then notice the cursors sort of stay in tandem, and I can press down and then delete, and then saw. So I don't know. That's a cool trick. It's also, notice one of the things, like the fact that my naming convention, they're all 6 characters. It helps you to, like, if you try to use naming conventions that are the same length, it will help you in doing things like I just did, if that makes sense. I don't know. But anyways, now that that's sorted, when I hit run, it should actually work this time. And by working, I mean it's not going to make any sound. Let's hear that. Yes, it's not making any sound very good. And that is because we've successfully applied our envelopes to the amplitudes of the corresponding oscillators. And by default, those envelopes, you know, up here, when I set the second variable or second argument to 0, that is why by default it's silent. If it was a non-zero, we'd hear something. Okay, now let's just, to check if this works, create a function called mouse pressed. And then in that, we are going to run the name of the envelope. So something like saw env, and we're going to call the method, I think, start or play. I think it's play. Play. Yeah, let's do that. Stop and then play. No, do you hear that? Every time I press the mouse button, we hear that saw tone. Look. It works. Okay, I think that's good for today. For the next tutorial, we're going to make parts and phrases and make a sequence.